Bismillahirrahmanirrahim. This video is from Network Analysis book by Mr. Alexander and Sadiku. And I'm starting end chapter questions now from chapter number 1 to facilitate students. So here we'll be doing question number 9.1 and 9.2. Just a small point that in this type of a question, now this is the question, the sinusoidal voltage is given and we have to find some parameters. So whenever you are doing this type of a question, that you have to keep in mind that this term is omega t, and omega t is in radians. And this is in degree, so it's a mixture of radians and degree. So you have to convert either radian into degree and then solve, or you have to convert degree into radian and then solve. So keep that point in mind. Now let's start the question. 4 parts. We have to find the amplitude, Vm, the time period, T, the frequency F, and voltage at time 10 millisecond. Okay, these are the two expressions that are generally used for sinusoidal signals. It could be written as Vm sin omega t, or another signal could be written as Vm cosine omega t. Generally, this form is preferred because from here we can directly convert into the phasor form for solving the question. Okay, so we compare these two now, these two. This is a given signal. And from here you can easily see that Vm or V maximum or V peak is 50 volt. And similarly, from here you can see omega is 30. So we'll use this value of omega. So the first part is now found out that Vm is 50 volt. Now the second part is the time period T. I'm sure you have learned it. I'm just going to repeat. The time period is given by 1 over frequency. And frequency and omega has this relation that the angular frequency omega is 2 pi frequency. So from here we can find 1 over f, and from there t. So t will be 2 pi over omega, or 2 pi over omega is 30 here, so we'll put 30. So this is the answer, 0.02094 second. But this is not in the scientific form. So we'll write it in proper form, which is 209.4 10 raised to the power minus 3, which actually is more appropriately can be written as 209.4 millisecond. So this is the answer of part B. Now frequency is simple. Frequency is omega over 2 pi, or 1 over t actually. So just again putting the value 32 pi and solving, we get 4.775 hertz. And finally, we have to find the value of Vt at t is equal to 10 millisecond. Now this is the equation given already for Vt. So all we have to do is put time is equal to 10 milliseconds. So 10 milliseconds, which is equal to 0.01 second, the equation will be V 0.01 50 cos 30 into 0.01. And as we discussed earlier also, that this is in radians, omega t is in radians, and then 10 degrees. So as we mentioned, we have to convert one of them. It is easier and preferable to convert radians into degree. And for converting, we take help of this. We know that radians is pi, which is equal to 180 degrees. So from unity method, we can say that 1 is equal to 180 over pi, 1 radian. So we multiply this. We multiply the radian with 180 over pi. So this is now in degree, and this is also in degree. And you can take help of your calculator to solve this directly, and the answer will be 44.48. So let's try solving. The key point here is that you have to make sure that you have cleared your calculator and you are in the D mode. Now this is not in D mode, so the best is we clear it. Shift, clear, 3 for all, equal sign, AC. So it's clear now, and automatically it has moved to D for degree mode. So now we can calculate 50 into cosine bracket already given 30 into 0.01 into 180 divided by pi divided by shift pi. So this portion is done. Then plus 10. Now there is no need of putting bracket because these are all multiplication, so they have priority. So plus 10, bracket close, equal sign. So you can see 44.4753 or 44.48 volt. So the first part is done. Now let's do another question, similar question exactly. Here we have to find current. This is the equation given, and amplitude. Now angular frequency we have to find, not normal frequency, then frequency, and then calculate the value at 2 millisecond. This is the general formula. This is our given value of I. So as we did in the previous case, amplitude we can write directly by comparison. So IM is 15 ampere. Part 1 is done. Part B is what is the angular frequency. And as I mentioned, angular frequency is omega. And omega is 225 pi from here. You can see this is omega. And which can be simplified to be 78.54 radians. Now the third part is find the frequency of the current. So we have found, we know the formula for frequency is omega over 2 pi. In the last slide we found omega, which was 25 pi, and 2 pi is 2 pi, or we can just from here, you know, it's omega is 25 pi. And therefore dividing 12.5 hertz is the frequency. And finally, now calculate the current at t is equal to 5 millisecond. So t is equal to 2 millisecond is equal to 0.002 seconds. So we have to be careful. I made a mistake. I had written 0.02. I had to spend a lot of time. Anyway. So putting in the value, and again we have to convert the radians into angle, same formula and same technique that we did. Let's do it again here. Clear 25 pi, sorry, 15 into cos 25 into pi, shift pi into 0.002 multiplied by 180 divided by pi. This is done, plus 25 equals, and if you have any doubt, you should put a bracket here also. That is 12.435 or 44. So this is the answer. But just for the curious mind, we will convert the degree into radians and see what happens. So we were up to this point, and we'll convert this degree into radians. So for converting degree into radians, now we have to multiply by pi over 180, not 180 over pi. And by solving, you get the same answer. So let's do. This is now the calculator is, you have to be moving into the radians. So clear, shift, mode, 4 for radians. So what do we need to do is convert this. Let's write the whole equation. This is just simple mathematics. Up here, you have to convert it into radians. So it is 15 cosine 0.593, and now it is in radians, so it will calculate, and you get the answer 12.439. So same answer. I hope you have been able to follow this. Please let me know through your comments. Thank you.